Okay, let's read this question carefully. The following questions relate to the following data. A survey of 400 randomly selected people found 301 who owned cars. 116 of them were women, and also 99 people who didn't own cars, and 59 of them were women. In each case, assume that a person is selected at random from the sample. Okay, anyone would get lost with these numbers, so best thing to do is to draw a table. So this table will be divided into 4 columns like this and 4 rows like this, and you will see why. It's because you can say here, if it's a man, we have either a man or a woman, and either have a car or no car. So you can do it like this, and then on the last one you do the total, and on the last one here you do the total. And so let's see what is given to us. That the total is 400 people. That was the first thing they said, that 400 people. So you know the total of everything is 400. Now 301 owned cars. So this means the total of the people that have cars is 301, because this is what we mean. This is the row for having a car that we made. So it's 301. And of course this means that 99 don't have cars. And they said that from the people who had cars, they told you here that 116 are women. So here you will put 116. And so since the total is 301 and there are 116 women that own cars, to get this one, you just subtract 116 from 301 and you will get 185 men who own cars. And the same thing for the ones who don't own a car. There are 99, and they said that 59 of the ones who don't own cars are women, and this means that there are 40 men who don't own a car, so that when you add 40 and 59 you will get the 99. Okay. And finally, the total number of men, if you add 185 and 40, this will give you all the men that we have in this sample. It will be 225. And the total number of women will be, of course, you add these two numbers, and you should get 175. Okay. Now that you have made the table, you can start answering questions A, B, C, and D. So I will do them one on each page. Okay, so the thing is drawn here already. That's nice. So we have the table in front of us. So find the probability that a woman is selected. So what is the probability of W? Let's mean by woman, by W we mean woman. How many women do we have? We have 175 women out of how many total people? 400. So the answer will be 175 divided by 400. And if you use your calculator, you'll get exactly 0.4375, which is, as a percentage, it looks nicer. It's 43.75%. That is the probability that a randomly selected person will be a woman. Okay, let's go to the next one. What's the probability of a woman, or, this means this symbol, or someone who owned a car is selected? So what is the probability of W or someone who owns a car, that we abbreviate as C? When I write C, I mean owns a car, and for not owning a car, I will write NC. So like no car, you read it as no car. But what's the probability of either a woman or owns a car? Is by the rule for or, it's the probability of woman plus probability of car minus, because in this case we have women that own cars, so this means there is an intersection between women and people that have cars. And so now probability of woman, remember we just did it, it's 175 out of the total 400. So I will write this 175 out of 400 plus probability of owning a car. So we have 301 people who own cars, 301, of course, out of the total 400, out of 400 people, minus, and let's just take this out, minus, now what's the probability of a woman and owns a car? So this would be this number here. The number here is the number of women that own a car, because it's the intersection between car and woman. And so the answer will be 116 divided by the total number of people, 400. Okay, and so this will be equal to, if you do the mathematics, it will be exactly 0.9, which is 90%, if you do it on your calculator. So this means that the probability that a randomly selected person is a woman or someone who owns a car is 90%. The next question is find the probability of a man or someone who didn't own a car. So NC, this is no car. You remember I said that instead of no car we write it as NC, the event. Again, this is an OR probability, so it's the probability of man plus the probability of no car minus the probability of man and not having a car. So probability of man is, you can see how many men do we have in total, 225. So it's 225 out of the total, of course, 400, plus people who don't have cars, how many? We have 99 people, so plus 99 out of those 400, minus how many men don't own a car? Men and no car will be this one here. This is men and no car. So minus 40 out of, again, 400. And so if you do the mathematics or the arithmetic on your calculator, this will turn out to be 0.71, which is, as a percentage, it's 71%. Okay, and so this is the answer to this third part of this question. The last part is find the probability that it's a man, again, or, so you, or someone who owned a car. So, or someone who owned a car. Remember that we said if they own a car, you write the event as C. If no car, we write it as NC. But now we don't need this no car. We already solved it. So now this will be, because it's an OR probability, it will be probability of man plus probability of owning a car minus probability of man and owning a car. So again, probability of man, how many men do we have? 225 out of the total number is 400, plus probability of having a car is 301 out of 400. So we have 301 people who own cars out of 400. Here it doesn't matter male or female. It's not conditional probability or anything like this. Minus, now how many males own cars? So this one, you want male and owns a car. So this is the number that you'll be looking at, because it's a man and owns a car. So this will be 185 men who own cars out of the 400 people. And again, if you do the arithmetic on your calculator for this question, you'll get 0.8525, which is nicer to write as a percentage because it will be 85.25%. And this answers this question. Just remember that at the beginning of the question, they didn't give you the table. I made the table for you, and then I showed you how to answer the question. So please go back and look at how I created this table. Read the question carefully in order for you to be able to create these tables yourself, because they're very simple to create. You just have to decide. You know that we have men and women, and you know that the characteristic here is that owning a car or not owning a car. And then you put the numbers and the totals. And this answers this question.